All right, so we are going to talk about normal distributions. So we've looked at discrete random variables, and we looked specifically at one discrete random variable, which was the binomial distribution. We've talked also about the fact that there are continuous distributions, and this is the one that we're really going to focus in on. So normal distributions are a little bit different because it's a continuous random variable, and because of that, it can have any real number. So we're used to binomial distributions being either 0 or 1 or 2, but there's nothing in between. With continuous distributions, there is something in between. And so because of that, each individual value doesn't really have much meaning. And so we're going to look at ranges instead. And so you're going to look at this and think, what in the world is that? Don't worry about it. We'll talk about integration later, but essentially what it's saying is in order to find a probability, you're actually taking the area underneath of the curve. So you're taking an estimation of the area underneath the normal distribution, right? And in our calculator, as we use our calculator to find probabilities, we're going to use a CDF for all of them because we're trying to find ranges. It's different. We're not trying to find a point ever. All right, with normal distributions. Now, what is a normal distribution? Where does it come from? Well, the normal distribution is kind of a naturally occurring thing. It happens fairly just naturally or just by chance in some senses. Most of the things that are normally distributed are things that you'll be used to, like test scores and things like that. These examples, the first one cracks me up. The chest sizes of English males are normally distributed. But there's a whole bunch of them here that they've just noticed, and the vast majority of continuous random variables, there's a lot of different possibilities, but most of them are normal distributions. And so the thing about the normal distribution that generally is true is that you need a fairly large sample size. So if I just give you 2 or 3 measurements, they're probably not going to be normally distributed. If I give you 100 or 200, then they might be, or probably will be. For different things. So you'll notice it says scores on tests taken by a large population because a small population doesn't necessarily give you a normal distribution. But this is the formula for a normal distribution. Remember we talked about a formula for binomial distribution? This is the formula for the normal distribution. And the difference here is that it's really complicated comparative to the binomial distribution. But if you look, there are 2 parameters. There's a mu here and a sigma, and then down here there's a sigma. Everything else is either a constant like e or 2 pi, or it's a variable like x. So x is our variable, just like it was with binomial distribution. Mu is our mean, and sigma is our standard deviation. So with binomial distributions, you had to know how many trials are you doing, that was n, and you had to know the probability of success. For a normal distribution, you have to know the mean and the standard deviation. It has to give you those 2 parameters. All right, so those are the 2 things you need to know. And once you know those 2 parameters, then you are good. So in terms of a normal distribution, this is how the probabilities work out. So you start with the mean in the middle, 1 standard deviation away from the mean. When you have, so the mean is kind of, you know where to start your curve. The standard deviation tells you how spread out the data is. And within 1 standard deviation, there's about 60% of the data, 68%. 2 standard deviation gives you even more. It gives you about 95% of the data. And it's symmetrical about the mean. All right, so that means that this probability is the same as this probability. And then within 3 standard deviations, you get most of the rest of it. So within 3 standard deviations of the mean, there's about 99% of the data, almost 100%. There's just a little bit left. And so as you go out this way, as your numbers get bigger than the mean, they eventually drop off. There's very few of them out without 3 standard deviations outside of the mean, and the same thing, there's very few on the bottom. All right, so we can use these probabilities. We can use this information to actually solve problems if we don't have a calculator for some reason, or we don't know, what the numbers are that we need. If they just give us a table. But generally speaking, we're going to use the calculator to find these. So we're going to use the calculator just like we did with the binomial distribution to find most of our probabilities, if not all of them. So let's look at a question here. there we go. Here's a question. It says the height of male students is normally distributed, and it has a mean of 170 centimeters, a standard deviation of 8. So you'll notice that it says find the percent of male students whose height is between 162 and 170. That's a difference of 8 centimeters, so that's 1 standard deviation from the mean. If we go back up to our little diagram, that's 34% of our data. All right, so we expect that that's our answer. Okay, so we can use that. Same thing here, 170 to 186, that's 2 standard deviations above the mean, right? It includes the first standard deviation and the second. So if you go back up to your diagram, it's 34% plus 13.59%. Okay, and if you add those together, you get that. So you can use those probabilities in that table I just showed you if you want to. The other option is to use your calculator. So if you're going to use your calculator, we're just going to take it out. You're going to go to your menu, you're going to go to statistics, and you're going to go to distributions again, and you're going to use a normal CDF. Okay? The lower bound and the upper bound are the numbers that it gives you. So between 162 and 170, you're going to put 162, and then you're going to go down and put 170. The mean and standard deviation default is 0 and 1. We'll talk about why that is later, but for now, we know our mean is 170, and our standard deviation is 8. And if we hit OK, and then we get our same probability, our 34.13. And then again, you can go back up here, just hit the up arrow twice, and you can just keep changing your boundaries because the mean and standard deviation are staying the same. So we're going to go 170 and 186 this time. And it's that. And again, it matches what we saw. So you can find the probability that a randomly chosen student from this group has a height of all of these different things, but you'll notice that some of them say less than and some of them say greater than. So I just want to look at those for a second because you can use the table, but in order to use the calculator, you just have to be careful. So we're going to skip down to this one. It says less than 162. So when I go to do my normal distribution and I want to do less than 162, I have to put in a lower bound, right? Because it goes lower bound to upper bound, but the lower bound is actually not anything that is a number. Like it's not giving me 10 or 12 or anything like that. It just says less than 162. So that lower bound, what we're going to do is we're going to put in minus, and then you're going to go to your 10 to the button, which I can't see, so let me make this bigger. You're going to just hit 10 to the, and then you're going to put in 99. So we're going to put like basically that's negative infinity. Okay, and then we're going to put in 162 for our upper bound. And we're going to hit enter. All right. Now, if you think about your table, 162 was 1 standard deviation below, I think, right? Because it's 8. So if we go back up here, whoops, no, where's my table? There it is. It's this stuff. And if you add that stuff up, you're going to get the 15% that we got here, give or take. It's 15.86. Okay, so that's how you do standard deviation on your calculator. Pretty simple. It's fairly straightforward. You can get a whole bunch of different answers, or questions, I guess, but you just basically just type into your calculator your upper bound, your lower bound, your mean, and your standard deviation. And that finds you all of these different probabilities. So I'm not going to go through all of that with you, but it's just to understand what you're doing. This is where we're actually going to end this video because I don't want it to go too long. And we're going to talk about the standard normal distribution in a minute. And then so in the second video, we'll talk about the standard normal distribution, and then we'll finally get to some problems together in class. All right, so that is just the basic introduction to the normal distribution.